we're talking about testing, we're going to focus in primarily on bond strength testing. We don't want to ignore the testing of the materials, i.e. the emulsions that are being used as tack coat materials, but we're not here to spend a significant amount of time talking about how we test, sample and test those materials. We will talk definitely about calibration of the distributor truck because this is an area within this arena that we've got a lot of feedback that needs certainly to be addressed. The three primary types of bond testing that we're going to talk about are shear, torsion, and tension. And then you'll see a fourth category that's called cyclic, which is a load, rest cycle is what we're talking about of any of the three up above. When we're talking about testing of the emulsions, we're talking about the basic emulsion tests that the Utah DOT will be using on any of their other products, emulsified products, whether it be for a microsurface, whether it be for a chip seal, or in our case for a tack coat. This slide is put together for the entire country, and so these are the standard tests that are typically found in most DOTs. If we were to compare this to what the Utah DOT requires, we may see some changes from that, we may not. There may be some additions, there may be some deletions. Just check with what is required here within the state. Truck calibration, however, is one of those areas that we hear an awful lot about. We've mentioned the NCAT test track down at Auburn University. An individual by the name of Buzz Powell is the one who runs that. Dr. Buzz is a great guy. He comes here to the conference on a regular basis. I know he's not here this year, and talking about some of the different things that are going on down there. Well, at the test track, as you may suspect, they keep track of absolutely everything to try to minimize any potential unintended consequences. And we talked about one of their unintended consequences in 2003 where they had the debonding. Where that comes into play in this discussion on tack coat is at the test track, they calibrate their distributor truck for each and every application. Now, they only have 500-foot test sections, and so they will try to line up their test sections so that they're applying the same thing over multiple test sections. But if they're doing a 0.10 shot rate, let's say, for example, of a given material, they will calibrate for that material for that shot rate and try to hit as many test sections in a row as they can. But the point is they calibrate each and every time. And Buzz has told me that in that calibration, the number that the computer produces as the shot rate has never once matched up with what they've actually measured. The error is not huge, but it's still an error. And as a research entity, they really care about making sure they're right down to the gnats behind. And so they want to make sure that if they want 0 as their shot rate, that that's exactly what they're getting. Where this comes into play in terms of this presentation and this workshop is Buzz is very clear that he certainly endorses the calibration of distributor trucks on a regular basis. And he too agrees that an annual calibration is a wise place to begin that calibration requirement. Jason talked about the three principal ways that we have in measuring what is actually going out the back of the truck. It could be by volume, which is the most common and which is most commonly used here in the state of Utah, maybe exclusively. It could be by mass or the ASTM procedure. If you're not calibrating on a regular basis, we would encourage that to occur. Let's talk about bond strength testing. Jason mentioned, as has been mentioned by myself earlier, the NCHRP 712 report. And one of the things that he mentioned that is recommended, that came out of that report, was shear testing. The actual procedure that Dr. Muhammad developed is going through the subcommittee of materials within AASHTO, and it's currently known as TP 114-15. For those of you that aren't familiar, this means temporary provision. This means the year that we most recently made any edits, either significant or minor, and then the designate test number. Excuse me, this test, we always as engineers like to come up with acronyms, and it's known as the Louisiana Interlayer Shear Strength Tester, or the LIST test. It can be either with a 4 or 6 inch specimen, so in metric that's 100 or 150 millimeters. It could come from cores out of the field, or it could come from lab-produced specimens, most typically coming off the super pave gyratory compactor. It has a rate of loading, vertical movement of 0.01 inches per minute, which equates to a little over 2.5 millimeters per minute, so a relatively slow amount of movement. Very important when we're testing our asphalt materials that we control temperature. And the standard test temperature here is 77 degrees Fahrenheit or 25 C. This is a common temperature at which we test different things within the binder world. There is an optional confinement load that can be applied on this particular procedure. And this is where it does vary and differ from some of the other shear procedures that are out there. Some have a confinement option, some do not. Some actually require it. But in this case, they have an optional 30 PSI normal load that could be applied. What they do is they wind up recording the ultimate loading, and then they just simply determine the pounds per square inch or the pascals based on that ultimate loading divided by the area. Here is what it looks like in terms of the jig head that goes onto the universal testing machine, and what they wind up doing is applying that load until we get failure, and we have a graph that's formed. And for those of you that recall the Marshall flow and stability test when we were doing Marshall mix designs, that graph probably looks an awful like a flow and stability test result. Here's what a shear test looks like in actual practice. This one comes from West Virginia. You'll see that the graph just simply rises up until it reaches a peak load. Once we get that failure, it's a very rapid decline. And again, for those of you that are familiar with the Marshall flow and stability, this looks a lot like what we had off one of those diagrams as well. There are folks that are actually analyzing this curve, looking at the area under the curve from an energy standpoint, and they're evaluating the test results based on an energy component, principally coming out of the University of Illinois. And that's an interesting way of looking at this. It certainly complicates the analysis, but it'll tell you something, a significant number of things above and beyond what just simply that P ultimate will give you. A bit of a variation of the shear test is known as the torsion or the torque bond test. It was originally developed in Sweden, and in Europe it's fairly common, particularly in the United Kingdom. Switzerland also does something similar to this. They're both automated, not animated. We don't have cartoon tests. Automated and manual versions. Principally, these are done in manual fashion, which is to the detriment of the test, quite frankly. It has been used in the United States both in approval products capacity as well as in a research capacity. It can be done both in the field and in the lab with a variety of configurations. This just happens to be the way that it looks in the United Kingdom. One step back, I mentioned that the manual, which is the more common, detracts from the test itself. And the reason why I say that is because repeatability is a very significant factor that we look at when we're evaluating whether a test is a good test or a bad test, if it's giving us reliable information or not. If we do a test such as this in a manual fashion, we inherently increase the variability because the same person doing the test repeatedly is going to apply that load slightly differently each time. You start throwing in different testers. A guy testing in the morning versus the afternoon, we can have significant differences. And so it really affects the repeatability of this test in a negative way. When we automate it, we help to reduce that variability significantly and pronouncedly. Tension testing is not uncommon in the world of engineering, particularly in a lot of the stuff that we do related to concrete, bridge decks and such. And so the tension tests that are out there for bonding are in general variations or modifications to some of the pre-existing tests that we've been doing on the concrete materials. There is another AASHTO procedure that came out of Dr. Muhammad's work. This one we don't have an acronym from, which I'm very grateful because it's the quality of tack coat adhesion to the surface of an asphalt pavement test. Now, I'm not sure what that acronym would actually say. But it too is going through the same process that the 114 test is. That's in about its second year through that process. There are some methods that have been identified that are used in regular practice in Texas, Kansas, and the state of Virginia. And one of the things that we'll hear about is that in ranking materials, when you test from a shear procedure versus a tension procedure, you don't get the same ranking of materials. And we showed the state of Virginia, they also have a shear test that they utilize. And in their approval of products, they utilize both testing regimes to determine whether or not they want to accept a product. Here are some of the specifics within that AASHTO procedure that Dr. Muhammad put together. It can be lab or in the field. It's a 6-inch specimen this time. You do not have an option for a 4-inch under this process. There is a seating load of a 20-pound compressive load that you'll place upon it for 3 minutes. You have a pull rate that's very slow of 0.08 inches per second. You wind up again recording the ultimate load, and that gives you what is known as the Tack Coat adhesion quality in either PSI or pascals. Again, from Dr. Muhammad, there's a slide. You can see the device in the picture. You just simply apply that load, seat it with the 20-pound for 3 minutes, and then you pull it apart and see what the ultimate load is. Again, getting a graph that looks a lot like what we saw on the shear test with an ultimate value at the top there. In the world of asphalt pavements, however, we generally don't have a pavement fail from a single loading event. Generally, our pavements will fail over time as a result of multiple loading events and some of the aging process that occurs. In the state of Florida, there's been a fair bit of research that tries to address this, and what they've done is taken some of these tests a step further and applying the load and giving it a chance to rest in a cyclic process. You can do this with any one of the 3 configurations, whether it be torsion, shear, or tension. They call theirs the Composite Specimen Interface Cracking Test. And this is principally, in their case, done as a tension test. But again, you could do this with some of the other processes and methodologies as well. Here's a quick rundown of how they handle it. They'll prepare the specimens, and these can be either 4 or 6-inch specimens. They will have 1 second cycles where they will load to a chosen peak value, remove that load, allow it to rest, and repeat this. And then they will just simply count up the number of cycles to a failure criteria that they have determined. Some comments about some of these different testing processes. Shear is clearly the leading candidate for the standard across the nation. One of the reasons for that is the testing equipment that's required of it is readily available in a lot of labs already. From the Marshall time, we wound up with a lot of load frames that are appropriate for this style of testing. What it does require is a jig that can be made by any competent machine shop. The test itself is quite quick. It offers good repeatability, certainly widely promoted, and it cleanly ranks the materials. The next most common test is the tension testing that we see over to the right. This can be done in the lab or the field, and we have identified, stepping back to the shear test, there is a field process that we've identified, but it's so uncommon that we have not chosen to change the slide yet. But back to the tension, it could be done in the lab or the field. It too is quick, it too is very repeatable. It also cleanly ranks the materials. We have a variety of states, more limited, that are looking at it. The issue though is that in general, materials that rank well in shear don't always rank so well in tension. Torsion, again, is a combination, or a variation, of the shear testing, common both in lab and field. It is also quick, but its repeatability is notably poorer from the before mentioned manual configuration, which is the most common. And again, from Florida, you have the cyclic testing. It's in a lab process. It's certainly more time consuming. It's very repeatable, and it also cleanly ranks the materials. So what do we have? We've got testing method playing a huge effect on the ranking. In general, shear and torsion rank materials different than tension and cyclic. Stiffer versus softer materials tend to be perform and be reported more favorably by one style or the other. And so this is certainly a point of confusion that I believe exists within the industry. Again, the state of Virginia has tried to address this by saying, okay, we recognize that shear has its advantages, and we recognize that tension has its advantages. And the reality is, in the field, failure of bond could come from either one of these mechanisms. And so they're using both methodologies in their specification, principally, again, for a product approval. They do have it on their specs where they could, if they have a failure going on, they could use it as a forensic tool. But in talking with the folks at their DOT, no one can think of a time when it's actually been used in that way. So let's talk about best practices. I mentioned at the beginning of the presentation when we first started that when we hit best practices, I really didn't expect I was going to offer you anything earth-shattering. What we're really talking about is common sense, standard best practices that should already be a part of your everyday paving operation. What we're seeking is a clean, dry surface. We're seeking uniformity of application. We want to make sure that all of our surfaces are tacked both horizontally and vertically. And if recall in Jason's discussion with you about your specification, all of these things are incorporated in the Utah DOT spec right now. Excellent. The other thing is we can see that we haven't been doing this just overnight. We've been doing this for a long time. That's another very old picture of a cleaning device that had a broom in the front and a blower in the back. A question came up at the beginning of the presentation. We were asking, what do you guys care about and want addressed? And milling was one of those items. I'm here to tell you that milling is a tremendous tool. I'm a huge fan of milling. Increased costs, it's one more step, but the results of it, I think, are almost universally very favorable. I say almost universally because there's always going to be those examples where we've got some issues that came about because of milling. But milling can be used to improve the profile. It's going to improve bonding characteristics. I have yet to find a research report or a failure analysis that did not indicate the true benefits that come from milling in terms of bonding. It does increase the cleaning effort. You incorporate water, you are creating dust, you're creating fine material, that requires cleaning. And of course, it certainly adds costs. You're adding one more step, more equipment, longer traffic control, all of that increases our costs. We wind up cleaning most of our surfaces principally by sweeping, and sweeping is an all right tool, but recognize that just because I swept a surface once doesn't mean I've necessarily got it clean enough. And so it's not uncommon, dependent upon the circumstances that are being addressed on a given project, to sweep a road, recognize that it needs to be swept again, and sometimes even more than that. We call for a dry surface, and what we're really saying is visually we want to make sure that it's moisture-free. Even in Dr. Muhammad's work, one of the things within his test research matrix is he indicated that they looked at dry, and they looked at moist, and they looked at wet. And they found wet to be really, really bad, almost universally. But they did find some instances where a moist condition under their definition actually provided some positive benefits on some of their tests. But yet they still recommend dry because Dr. Muhammad very quickly will point out that even though there's some very select examples where a little bit of moisture proved to be beneficial, in general, dry was by far and away a much more preferred state. And so their recommendations, as well as ours, is to be dry. Here's a situation, however, that we do see come up at times with milling. Anyone else ever seen one of these before? Kevin's seen it. A few other people have seen it. I've seen it. My criticism of this picture is the fact that this was taken at this stage indicates that they were willing to live with this. I would not be happy with this. We've all, maybe not all of us, but very many of us have seen milling operations where we have a prescribed depth. And we start doing this milling and this sort of thing happens where scabs are peeling off, revealing some issues with the bond between the layer that we were hoping to not have to go all the way through and what's underneath. You have some choices at this stage. One choice might be that you actually bring the milling head up farther and you don't take quite as much material off. I would submit to you that that's probably not your best choice. And the reason why I would submit that is clearly we've got some issues going on with delamination underneath there, and just simply because I bring it up doesn't mean I've eliminated that problem. More appropriately and more costly, and potentially an issue with the amount of quantities that are going on the project, is to go deeper into this material and go into that surface that's below. Certainly not the intention to start with, but we now eliminate our real problem child that's going to come back and bite us in the future if we haven't taken care of this. Again, since we're going deeper now, instead of, let's say, a 2-inch overlay that we were hoping to place upon this, that might mean we're now into a 3-inch realm. Have we accounted that for the materials? Probably not. We got more quantities that would become necessary for this project. It's going to increase the cost. But recognize, this is giving us a tremendous benefit. That benefit meaning that it's identified a problem that's going to cause us issues into the future, and it gives us the opportunity to actually correct them now and not get surprised and hurt by them in the future. We want to make sure that we match the application to the conditions. One of my very few criticisms of the 712 report is when they make recommendations on application rate, they will provide you with a single value for 4 different scenarios, whether it be fresh asphalt, milled asphalt, concrete, so forth. I do not believe that one size fits all within the different categories. Let's just take a fresh asphalt, for example. If we're doing an SMA, placing that on top of a relatively fine, tight mix, we may not need as much tack coat as if we're placing that upon something that's more open with more surface area. The style of milling is going to have an effect on the amount of surface area that's available and needs to be tacked when we apply a tack coat to that milled surface. So there's a range, in my opinion, of appropriate shot rates given different conditions. I think it's great to look at different shot rates within classes of a given condition, whether you're doing asphalt or concrete, for example, on this overlay. But within a given category, I think that we should have a wider range. I think that we need to match the materials and the residual rate to the conditions that exist upon both the material that we're putting the tack on and the material that will go on top of that tack coat. We want to verify that application rate. Highly recommend using the meter that's on the truck, using the dipstick, and making sure that our yields match what we intended. And we want to resist tacking too far ahead of the paver. Your specifications say that you have to cover up your tack coat at the end of each shift. That's a good spec. Jason mentioned that in some locations they get a little bit crazy, and I can tell you the biggest one that I've heard about is in the province of Alberta. I know of conditions where they will tack on Monday for everything they expect to do that week. That seems a little crazy. But even in a situation where you're tacking once a day, you have to recognize that in some instances that's an okay thing because you don't have a significant opportunity for contamination. But I can tell you of an example that I saw that I refer to as the first fiber mat application in the state of Montana. It was north of Great Falls, Montana on Interstate 15. It was in the fall of the year, and there's a lot of grain fields that line either side of the interstate in that region of the state. Plus, it's off the front range of the Rockies, which is always windy. And they did their tack coat in the morning, and the custom combiners showed up sometime mid-morning and started cutting wheat, and all kinds of chaff was getting blown across I-15, and I'm telling you, chaff and asphalt stick really well together. And so they got their first fiber mat application. You got to recognize that things happen. And so just because we normally tack a full day, there may be situations that we have to recognize that, hey, we would love to do our full 12-hour shift or what it might be, but we recognize that we can only do it in steps on this particular day because of different things that could happen. You know, paying attention to what the weather forecast says. Just because you plan on working 12 hours doesn't mean that Mother Nature isn't going to cause you an issue in the afternoon. Just got to keep that kind of stuff in mind. Let's do some critiquing. This is a shot from a project that was taken in southeastern Montana. The contractor on this is, the head of this is a very dear friend of mine that I've known for a lot of years. We went to school together, we hunt and fish together, we carried a lot of elk out together. This was an NCHRP project. This was a warm mix research project that NCAT was the principal investigator on. Because of that, there was a lot of people out there. The state materials engineer, the state bituminous engineer, the state materials testing engineer, and the state construction engineer from Montana DOT were all there. From NCAT, we had about a half a dozen people out there, including 2 of them with PhDs. The regional engineer for the Asphalt Institute, who may or may not be talking to you right now, he was also out there. We had a number of folks who should have been able to look at this thing and see what was good and what was bad. What do you guys like? What do you dislike? Okay, one at a time. Howard, what did you have to say?
There's too much material out in front.
Our tack spread doesn't match the width, and that's my number one complaint. I'll tell you what, I didn't even notice that until I was looking at this picture however many months and so forth later. You know, let's start with the positive. That's a beautiful milling job. It really is a beautiful milling job. Another positive, we got uniformity of our tack coat. But I'll tell you, in the state of Montana, this is an example where Montana requires a 1-to-1 dilution and a shot rate of 0.10 gallons per square yard, regardless of what it's going upon. And so we can see a little bit of salt and pepper in here. I would like to see that tack rate go up just a little bit. I don't think it's too low, significantly low, but it's not as high as what I'd like to see. But there's the real issue that I know a number of you saw, and Howard was given the opportunity to vocalize. We weren't quite as wide as we need to be. This afternoon, we talked about longitudinal joints. We're going to emphasize just how important it is to get a good bond between that lower lift and the longitudinal joint. It's a critical area. And yet, even with all the expertise that was out there, none of us saw it at the time. None of us. Let's do another one real quick. This one comes out of the state of South Dakota. Again, what do you like, what do you dislike? Well, let's start over here at the longitudinal joint. We notice that that second ribbon on this side has already gone down, and clearly they tacked wider in this case, like they should have, than what that ribbon was. So we like that. What about what we see here, though? Very dirty surface. And perhaps they had it clean at one point, but clearly, as we see it in this shot, that tack coat that's going to be sprayed is going to hit that material, and there's no way it's going to penetrate through that dust into the pavement that's down there. And when the equipment and trucks hit that material, it's going to pick it up. I guarantee it. We don't see any tack on this surface, and you're going to hear that we recommend, you've heard it before, tack between each and every lift. However, I'm not going to offer too much criticism because they're paving this next, they're not paving this. And so I'm going to assume that they probably tacked that when it was its turn. This is a fairly light application. If you didn't notice it before, look at how much of the surface below this tack coat you can see. And this is fresh. We haven't had any of the water leave. There's no break that has occurred yet on this material. So definitely I would like them to increase that tack coat rate. We'll get a couple more of those before we're done. Let's talk about the distributor truck. A few things that really are crucial with the distributor truck. First of all is that liquid temperature. We need to make sure that it matches the material in question. We have two reasons for that. One, dependent upon the material that you're spraying, their temperature ranges do vary some. If you look at the reduced tracking materials, for example, they tend to have a slightly different optimal range compared to your traditional slow sets. There is some overlap, but they're slightly different between the two. Another thing is we need to remember that we have a standard temperature of 60 degrees Fahrenheit. So we need to know at what temperature we're actually spraying to be able to do those calculations. It's another area where the error that's introduced is not always all that great, but it's still yet one more error. And if you start accumulating errors, pretty soon you can have a pretty big one. The calibration of that distributor truck is absolutely important in our opinion. First of all, we want to make sure that spray bar height is the height that it needs to be. And you're going to hear that we recommend a triple overlap. That equates to about 1 foot of height. We want to make sure that the spray bar pressure is adequate and uniform across the bar. Just because we have good pressure on one of our nozzles doesn't guarantee that we'll have good pressure coming out all of them. The nozzle angle is absolutely important. We'll show you that diagrammatically. The nozzle selection. Quick question, who knows what nozzles come with a brand new distributor truck from the supplier? What are they intended for? Chip seals. I heard somebody say chip seals. That's absolutely right. Is a chip seal nozzle the same one you'd want to use for a tack coat? Not at all. Every one of our manufacturers, and we have, did those go around yet, Jason? Okay, they're going around. Every one of our manufacturers provides different nozzles for different usage. Whether we're talking application rate of different emulsions or if we've got PG binders going through there, they want to make sure that you use a nozzle that's most appropriate for the given application material and rate. The trucks, as was mentioned, come with a chip seal nozzle. And I know a lot of folks that will tack coat with those nozzles. They've never changed any of them. And admittedly, on a nice straight where you can get that truck really rolling down the road, I've seen guys that do a nice job. We showed a picture where they will shut off nozzles, do different things. Much, much better choice to actually put the right nozzles on your spray bar. It doesn't take that much time to change them out. Thermometers and volume meters to make sure that we're in that temperature range and we know how much material is going through our truck. This is what we're trying to seek. We desire and we recommend triple overlap. In looking at different specifications, I've seen a lot of specifications that require triple overlap. I've seen some specifications that will call for either triple or double overlap, which would mean that we'd be at this height, eliminating this bottom third. I've seen some specifications that actually require double overlap. I have never seen a specification for Tack Coat that allows for a single lap of this material, i.e. only being about 4 inches high. So we want to be about 12 inches to give us that triple. 8 will give us double. We never want to be less than that. We also want to make sure that the nozzles themselves are at the proper offset. That is going to be between 15 and 30 degrees, and we want it consistent all the way up and down the bar. When we were in Puerto Rico last week, we went out on an actual project, and to that contractor's credit, they had changed their nozzles to the right ones for the Tack Coat. But each and every one of them was at a different angle. And so we let them know about that, and they did a great job of quickly adjusting that. Here's what happens if you don't have the right angle. If you wind up lining them up essentially parallel or closely parallel to the bar, you're going to get the fan from each of these two nozzles interfering with each other, and that's going to disrupt your continuity of application across the bar. If you rotate it too much, you've set yourself up for a perfect application of zebra tack or a cornrow, where you're going to have empty spaces and heavy applications in between. What we want is the angle to be between that 15 and 30, so quite frankly, I think this is a little too much in this slide, but we want those fans not interfering with one another and assisting one another to create that uniformity. Because if we go back to the slide right here, if, let's just say, for example, this nozzle became compromised where it was partially or completely clogged, if we've got that triple overlap, the two nozzles on this side and the two nozzles on this side of him will help cover that area and minimize any disruption that occurs. Will it be slightly less in here? Absolutely. But let's recognize that that driver sitting inside that distributor truck, if this nozzle doesn't happen to be in a place where he can physically see it, he may not actually notice it. And unless somebody outside the truck is telling him about it, he may not know until he gets down to the end of that run that he's doing that he actually had an issue. And so having that triple overlap, we may still be okay. So consult your manufacturer within their owner's manual. They will tell you which nozzles they recommend for the different usages of that truck. And remember, one size does not fit all. These are the nozzles that you would have saw from Etnire, and you'll notice that they have different usage, and it's this number 1, which is that part number, which is what they intend for Tack Coat applications. This is not a Tack Coat. We're not putting down Tack Coats at this extremely heavy rate. This is probably a chip seal. But let's take a look at this area, and we can see in this slide specifically what we're talking about. We got two nozzles that are clearly compromised, but because of triple overlap, they're helping to cover for us. Cleaning the distributor truck, it's, you do have a handout that talks about if your truck is used for more than one material. And again, what we're most concerned about when we talk about this is if you've got a truck that's normally used for an emulsion, but for whatever reason you're needing to put a hot asphalt in there, a paving grade asphalt, make sure that all of the water is out of that truck so that you don't create a little bomb. The quality of the product can be affected, particularly when you're changing from one material to another. This one varies dependent upon the compatibility and the consistency between the two dissimilar products. It's always best to completely empty it if possible. So for you inspectors out there, here's a short little checklist of some things we would recommend that you pay attention to. Check that truck setup. Is that spray bar height and operation rate about 1 foot so you're getting that triple overlap? Are they using the appropriate nozzles? And if you're fairly new to this and you don't immediately recognize whether or not those nozzles may or may not be right, check it out. Ask to see the manual. Ask to know what number of nozzle is being used for that particular application. Make sure that orientation is between 15 and 30 degrees and very consistent up and down the bar. Visually, you can very quickly see that. Check the application rate with the gauge in the truck and recognize that there may be a little bit of discrepancy between what actually went down and what that gauge says, but it should be within the range that you're normally looking, and that calibration differential that we're asking to be a part of the annual process of maintenance on these trucks should then very quickly give you the opportunity to calculate the actual rate. Collect samples because we definitely want to test this material, or if there is an issue in the future, we may want to have that available for testing if it's not a routine part. Know what the application rates are desired. In your specs, you specifically call for a particular application dependent upon the surface that you're on. On your projects, make sure that they match up. Visually inspect the application. When we've showed you different pictures of poor application, and as an inspector, you should be able to look at what's happening out there and recognize, is there anything that's going on that I would need to be addressing with this contractor? And from the contractor side, that same is true. Contractors really don't want issues. I've yet to find a contractor who's looking for a fight with the state. It has different reasons why it happens. And so from the contractor side, they're also looking at this to make sure that they don't see anything that could create an issue. And then let's make sure we're verifying that. Again, we recommend that there is a yield component to your inspection process, and using the volume calculation is what we recommend. Just an example of an inspection sheet that comes out of the state of West Virginia. One of the things that we really like about this is the simplicity of it. It's very straightforward. In their case, they have a range, and they talk about undiluted and diluted material, and they talk about typical residual values that they are seeing from their materials. Their typical residual value of undiluted is about 60%. If it's diluted, then the 1-to-1, it would be a 30%. One of the questions that people have asked, where'd you come up with that 57 on that example? That came from because in South Dakota, that's what they normally get, and the guy who put that slide together is from South Dakota. So just know what your residual value is on your materials. They have these application checks, which are also very nice in our mind, because that gives you that yield calculation fairly quickly. Another critique. What do we like, what do we dislike? It probably, on the screen with this lighting, it's not showing up quite as well as what it does on the computer screen, or may show up on your slide. But in general, that's a fairly uniform application. Overall, not too bad. There are some questions about the milling operation, but in this instance, there was a brick pavement below this. So even though you have some areas where you have some delaminations that have occurred, you can't go any deeper on this material. And so as much as they would like to, they couldn't. But the real thing that we see is that there was a line that got missed. There was a nozzle that wasn't getting its material out, and the nozzles on either side of it were not providing significant insurance coverage in this case. So the contractor came back, and with 3 nozzles going, they filled in that missed line. Here's another video. This one happens to come off the airport in buildings. So this is an FAA P401 specification application. Nicely uniform, very consistent, fairly high application rate. Let's talk about everyone's big headache with Tack Coat, tracking and pickup. All of these pictures come from our friends at Road Science. Clearly, we talk about how the longitudinal joint is a very critical area to get a good bond. Another location that's absolutely critical is in those wheel paths, because when the traffic that this road is asked to carry is imparting its stresses and strains into that pavement, this and this location are where they're going to be imparting that load. And yet, in this picture, we can see clearly that this material was removed by the construction traffic. This is a polymer modified tack coat. If you can't see it real well, these are rubber bands that were formed because the polymer within this application stuck to the wheels. Fairly common example. We've got a little bit of inconsistency, certainly, between the light and dark areas, and we can see where that truck has tracked it off. Let's start by talking about spray pavers. One of the reasons why spray pavers are promoted is because they eliminate the opportunity for tracking. For those of you that aren't familiar, you guys do use them here in the state of Utah. A spray paver is a single pass where both the hot mix and the emulsion for tack coat are applied through a single piece of equipment. Oftentimes the tack coat that's used in a spray paper application is polymer modified. A CRS2P type product is fairly common. These generally have quite high application rates. Residual rates tend to start somewhere close to 0.10, about what we're normally spraying our tack coats, on as high as about 0.20 residual rates. A couple of different proprietary products that we're showing as examples. There's only two pieces of known equipment that are available. Caterpillar has been saying for a number of years that they're developing a spray paver and they will market a spray paver. And I don't know when that's going to happen. When I talk to them today, they'll still tell me, yep, we got one coming. Not sure when. Right now, there's a fairly limited number of states, you guys being one of them. There is a product that's available from a company, Blackledge, the same people who developed the trackless tack, called UltraFuse. This is not an emulsion, it's a polymer modified oil that can go through a regular distributor truck. They're marketing this as a spray paver application without the spray paver. And there's been a fair bit of work with this in the Southeast. The test track has done a lot of work with this. The state of Florida has done a fair bit of work with it. And so far the results that I've heard have been positive. So for those who are thinking, well, we might want a spray paver type project and call for that without having to dictate a spray paver, this is an option. How much of an option it might be here in Utah, one would have to investigate. So I mentioned that there's two suppliers. Roadtech has theirs and Vogley has theirs. Now Vogley has two different configurations. The configuration we see in this schematic shows the tack tank mounted to the back of the paver, and this can be done as a retrofit on some of their other pavers. The tack tank for the Roadtech is here in the front. In the vast majority of the spray pavers that are out there, a material transfer of shuttle buggy is a requirement in order to convey that material into the paver itself. So here's what we have from Roadtech with their shuttle buggy as well. And here's what we have from Vogley. And I showed you that the spray jet attachment was here in the back. Here it is in the front. And so there is a couple of different configurations available from those folks. Here are some of the proposed benefits. One, no tracking. You can't track. This material goes down right in front of the screed, right in front of the augers. And so there is no opportunity for anything to track this material away. They claim, and a lot of research has indicated that the claim is valid, that you get better bonding, which should increase your overlay life, should reduce the rutting, should reduce cracking on our pavement. Also a claim is improved joint compaction. Also easier compaction, that Tack Coat's helping provide confinement. The other thing about these is they tend to be fairly thin lifts, and so inherently they tend to be pretty easy to compact in the first place. The downside is that you can't really see what's going on underneath. And where this comes into play is if one of those nozzles becomes compromised. You just simply can't see it. But our application rates are quite high, and again, a lot of discussions with Dr. Powell from NCAT, their experience has been that the concern about not seeing is somewhat muted by the fact that these applications being so high that the material tends to create almost a bit of a bow wave in front of the auger and screed. The examples that we use throughout the country include both you guys and Kansas, and it's called a self-priming paver. And if you're familiar with the folks who first promoted this, it would not come as a surprise why I call this the Coke specification. It's required that you have a hopper, that the tank be on board, you have a system for measuring that application volume, that of course you have a spray bar on the paver or else it's not a spray paver, and that you have a heated and variable screed. All of the specs that I've seen, including your guys', incorporates and requires a material transfer vehicle. Let's critique again. What do we like about this particular shot that we see here? I'm telling you, I find one thing I like. What's that? He tacked the edges, absolutely. I like that. I mean, and it looks like a pretty good amount of tack on the edges. It doesn't look like he skimped it. And the downside is he doesn't look like he went over the top of that edge. He may have only got a bit more around the edges would be nice, but he did tack his edges. Other than that, I'm not real thrilled with this. You cannot get the same degree of application with a wand and a tank as you can with a truck. Now, I can't see all of this, and I'm not the one who took this picture, and this might just be a patched area, and so it may be a scenario where bringing a full truck in may not have necessarily been desirous, but I'm still going to tell you that it would have been better with a truck. How about this one, little trench patch that we're doing? We got tack in there, but we don't have any of our vertical faces. Pretty high application, but let's make sure we get along those edges. One more before we move on. Again, another trench. Clearly a hand operation, and highly inconsistent. Again, our vertical edges are not getting hit very well. One more video. Jason and one of my fellow AI engineers were on their way to a Tack Coat workshop when they saw this operation in its finest. He's getting his tank ready, and let's tack. There we go. Probably not the best example of Tack Coat operations. This is what we're striving for. We can see the truck here in the background, a little bit brown still on our coloration. Nice milling job, nice uniformity across the way. We can see the curb and gutters getting hit with Tack Coat as well. Let's do a quick review and summary. We've got about 10 minutes left here, guys. So stay with me for these last 10 minutes. First and foremost, in the world of paving, it's not uncommon, you're going to hear this afternoon again, that the experts don't always agree on a given topic. The same is true with our Tack Coat. We try to address this by addressing some of the common questions. And I think you're going to see some of the common questions are also on the wall from the questions that were asked earlier. First question, this was definitely asked, do I still need tack? Where it comes into play is most commonly on a milled surface, because there is research that indicates that the bond strength on a milled surface doesn't always benefit from Tack Coat. There's research that indicates that it does. If it's a fresh pavement, and this is the scenario that was asked today, I put down a ribbon, I've got another one going on in short order, do I still need to Tack Coat? And finally, late seasoning and cool days. And this really comes into the reality of what happens with an emulsion. With an emulsion, you really see a huge benefit in terms of time and performance with some sunshine on it. And when we're in late season or nighttime paving, we don't have that. The one I really want to spend some time on is this middle one. This is a byproduct of our history. For those of you that have been in the industry long enough, in this room, when we asked, there's a lot of hands that stayed up for a long period of time in terms of history. You recall our mix designs from days before Super Pave. By and large, around the country, we found that our optimum asphalt contents before Super Pave were higher than what they were after Super Pave. And our gradations are different. All of that equates to the available asphalt that we once had on a mix design. The effective asphalt content was higher than what we tend to see today. Where that comes into play on this is if you had more available asphalt, you had more asphalt on both those layers, that would have potentially caused you a bonding mechanism between those layers. Our Super Pave mixes today, and now let's start throwing in some of our recycled materials on top of that, tend to be significantly drier, and they tend to not have near as much available asphalt to create that bond. And so while we'll tell you that you can probably reduce your Tack Coat rate on a fresh surface, you will not hear us recommend the elimination of it. And the same is true on our milled surfaces. While I can point you to research that indicates that there may not be as much of a need, we're still going to recommend it. And it all goes back to our cost-benefit analysis. When we look at what a Tack Coat actually costs in terms of the project, it really isn't all that much. But when we remember how much it's going to cost if we don't get that bonding and that premature failure or maybe catastrophic failure, all of a sudden that value that we receive from that relatively minor investment is huge. So we recommend tacking every single surface. When can I pave on the emulsion? Has it broke? Does it need to be set? And what about spray pavers? I'm going to start at the bottom. Spray pavers are an entirely different animal. The spray paver is a bit of an apples and oranges comparison. If we want to talk about spray pavers, let's talk about that afterwards. Bottom line is, yes, you're paving on an asphalt emulsion that has not even had the opportunity to break or set. And so the question becomes, well, if you don't have to pave on those, if you can pave on those, why can't you do it with the regular material? Remember, their application rates are way higher, and the materials that they're putting down tend to be a little bit different as well. We recommend waiting till after it is broke. Now, we will tell you and admit that waiting till it is set is certainly preferred. The reason why we choose to say wait until it is broke is because you will have lost some of the water. You have a very clear visual cue as to when that has occurred, and it's not readily as easy to determine whether the asphalt has actually gone all the way to its set condition out in the field without actually doing some real tests on it. I can look at it and see whether it's still brown or not. I can look at it and see if it's black. And this really is a compromised position. We recognize, again, that set would be better, but in terms of practicality, we think that it being broke is a good place to land on and to stand on. Just visually, there's some examples. Our unbroken emulsion on the left, and after it's broke, nice and jet black there on the right. What is the optimal amount? Your surface type and its condition will help dictate the answer to this. What we recommend, and we'll show you in terms of gallons per square yard residual on 4 different categories. And we chose these categories because they match up exactly with what the NCHRP report reported in terms of categories. So we have new, existing asphalt, milled surface, and then your Portland cement concrete. We also show that if you've diluted it, looking at a 1-to-1 dilution, or undiluted, excuse me, or a 1-to-1 dilution rate, the ranges that get you back into this residual category that we're seeking. Again, we recommend that specifications be written in terms of residual asphalt, and we recommend that the adjustments are made on an individual basis based on the asphalt that you're using and whether or not it's diluted to get you back to that appropriate residual value. When to re-tack. And this picture should look familiar because it's the same one we saw before when we were talking about tracking. Also contamination. If in doubt, we recommend retacking. And one of the things I commonly say is if you've noticed that there's enough of a compromise to that tack coat that you're even asking the question, you've probably already provided yourself with the answer even if you may not want to hear it. Sometimes retacking is absolutely necessary. In this case, I would highly recommend that on this project that they would have halted, brought that truck back in, covered up these 2 areas that they needed to, let it break and continue on with their project. Inconvenience, absolutely. Nobody's going to want to do that. But for best performance, that would have been a good choice for them. Dilute or not to dilute? What I will tell you is that we certainly recommend that dilution is best controlled by the supplier. What we have heard is that in your specifications, that's where you're trying to maintain control over that dilution. It's a good place to be. The real key is that word control. Knowing exactly how much water you're adding to that emulsion so that when you do your calculations back to residual, you can account for all the different factors to get to that right number. So verify the dilution amount, most commonly that 1-to-1 rate, but you guys in your spec, you talk a 1-to-1 and a 2-to-1 rate depending on some different scenarios. Remember that out in the field, dilution cannot be used to stretch asphalt. All you're doing is adding water, you're not adding asphalt. Residual value, again, is key. In this workshop, we certainly recommend that the suppliers do that dilution. We don't have a problem with contractors doing it so long as it's properly controlled. What about bond testing? This really is the area where there's more work being done than maybe any other within tack coats. There are 4 different classes: shear, torsion, tension, and then that cyclic hybrid category. All of them have advantages and disadvantages. There isn't a clear winner right now. We do believe that as time goes on, one is going to rise to the surface as the preferred method. Currently, that looks like shear testing. However, there are those who would argue against it and promote some other option. So it's a stay tuned category. Some areas of known agreement is that layer bonding is absolutely vital. Here in the state of Utah, I know you have examples of premature fatiguing that's occurred where with forensic analysis you can go in and you can see that there's bonding issues that have occurred. It's very common to find a crack that is in the upper lift of a given pavement and not find it anywhere further down in that surface. That's called top-down cracking. A number of folks believe that that's got a significant relationship to bonding performance. Other things come into play on that. Don't leave here thinking that's the only thing, but that's one area where we're seeing it. Surface preparation is absolutely vital. Clean is a huge key, and we recommend dry just because that is a much more easily determined state. Much like the difference between a broke and a set tack isn't always that easy to know the difference between them. Knowing whether or not it's dry enough or if there's an inappropriate amount of moisture isn't always that easy to determine either. And so for the sake of safety and on the side of caution, we say dry. Milling will improve performance, but that does add to the degree of cleaning that is necessary. And remember that milling operations have water in it that can create mud. If you're in a scenario where it's nighttime paving, you have to mill and fill that up in a given work schedule, a shift, that can become a bit of an issue for you without a doubt. Application quality is vital. We want that consistency both tangentially and longitudinally down our road. We want to make sure that that Tack Coat truck is set up properly, that we have the right nozzles on there, that it's been calibrated on a regular basis, and that truck is well maintained. A lot more on this afternoon, but on those longitudinal joints, we want to make sure that we get good bonding, and you'll hear that we recommend, if you're using an emulsion to help create that bonding from the Tack Coat material, that you do a double application at that longitudinal joint. Excessive tack is bad, but the opportunity for that to occur is far less than not having enough. And so yes, we do want to be careful that we don't get too much of it out there, but we'll tell you, and our experience and the vast majority of people's experience that we've talked to, is that it's very rare to see excessive. So again, the Tack Coat rate will depend upon the surface, whether it's fresh, weathered, raveled, or milled. There's certainly a need for more research, particularly in that bonding area. We do think that we need to come to a consensus on what is the right bond test to perform. Again, remember, there's two methods going through the subcommittee on materials as we speak. And we recommend, highly recommend, as does the NCHRP report, as does NCAT, as does NAPA, that Tack Coat be treated as a separate item. So recalling our learning objectives, by far and away the one that I wanted to make sure that we drove into you today, if you didn't realize when you came in here, is that layer bonding is absolutely vital. We have gobs of evidence for that, both from the research side and from the practical field side. Making sure that we handle these materials appropriately, consulting with the suppliers to help make sure that that is done. To recognize that there are some different tests that we can do both in the field and in the lab to determine that bonding performance. Again, shear seem to be rising to the surface. We'll see what ultimately prevails. And those construction best practices, getting it properly clean, which means that you don't have additional dust, excess dust there, that there isn't any mud on there, that if additional, once you've had it clean, if dirt winds up back on there, that you go back and clean it again. A dry surface to get good bonding. And so with that, we'll take any additional questions that you might have. We are almost exactly 12 o'clock straight up. And recall that we want to make sure that you get those evaluations into us. You'll be doing a separate evaluations for this afternoon's workshop on longitudinal joints.